part one of variation equations. Before we jump into talking about these variation equations, we are going to review what needs to happen for solving an inequality. So we look at x squared minus 36 is less than 0. We always start these by factoring. So x squared minus 36, that's a difference of squares. Factors to x minus 6, x plus 6, which tells us that our two zeros are a positive 6 and a negative 6. We take those two zeros and put them on a number line with our smallest number on the left and our bigger number on the right. And we have open circles because there's no equal to. We take a look at the parent function and it's a parabola. It's positive, so that means it would open up. So we do a quick sketch of that really quickly, I guess. All right, then we take a look at our inequality, and our inequality tells us it's less than 0, so we're looking at the part below the line. When it's greater than 0, we're looking at the portion of the graph that's above the line. This one says that we are going from negative 6 to 6 with parentheses. And then if we were to sketch that, we would shade in the part between negative 6 and 6. Okay, so let's talk about variations. So we have some two different types of variation equations. Direct variation is y equals kx to the n. And inverse variation is y equals k divided by x to the n. And the k value in both of those is called the variation constant. So go ahead and pause, make sure you get that written down, and then come back and join us for our first example. These questions are almost always word problems. So you can pause and get everything written down or just write down the important pieces. But I think you're going to want to have the majority of it there so you can see how it's formatted for other ones that you encounter. This says when you swim underwater, the pressure in your ears varies directly with the square of the depth at which you swim. All right, so the way that they have this sentence set up tells us several things. One, it says it varies directly. So we know that this is going to be a direct variation equation. So we'll use that equation. The other thing it tells us is that it is with the square of the depth. So the square, that's what goes in for that n value in our equation. Our n is going to be squared. If that word wasn't there, then we would not have an exponent, but because square is there, we will have an exponent of 2. Also, this first mention of pressure, that would be your y variable, and it varies directly with the depth at which you swim. That's your x variable. So all of these types of word problems are going to be set up that way, where they're going to say something is your y, and it varies either directly or inversely with another variable, which is your x. So we know, because of directly, we're going to be using the equation y equals kx to the n, and we know that this n value right here is going to be 2. So we're going to replace that n with 2. So it wants us to find the variation constant on part A. So we're going to take this equation and we're going to substitute values in. So we said y was pressure. So here they told us 4.3 is pressure, so we're going to put that in for y. We don't know k. Remember, variation constant is k. That's what we're solving for. And then x is depth, so we're going to put 10 in for x. And we said that our x value is going to be squared. So we're going to take 4.3 equals 100k. Divide both sides by 100. And we find out that our k, or our variation constant, is 0.043. That's half of what this part A asked us for. Find the variation constant. We just did that. But notice it says, and write the variation equation. So we need to make sure we do that part also. So the variation equation is when we take the constant and put it back in. You don't put a value in for y. So we have 0.043 in for k, but you do put the squared part in. So x and y stay as x and y. We put our k and we put our exponent. And that's the variation equation. So 2 answers on part A there. All right, part B, determine the pressure you would feel on your ears 50 feet below the surface. So determine the pressure. That means we don't know it. Well, which one is pressure again? Well, that's our y variable. So that means we're solving for y. So we don't know y. We keep the same equation we had up above, 0.043, and you feel on your ears 50 feet. That's depth. So that would go in for x squared. Calculate that, then we get 107.5, and then we're talking about pressure, so we have to see what units we use for pressure, PSI. So 107.5 PSI would be the pressure. Part C, if you feel 65 PSI on your ears, what's the swimming depth? So this time they're giving us the y value, so we put it in for y. We use the same constant, but we don't know x, we don't know the depth. So we divide the constant by both sides to isolate the x squared. So we have x squared equals 1,511.6. So we find out that that is approximately 38.9. And what are we measuring depth in? It said feet. So 38.9 feet. All right, we're going to try another one. I want you to hit pause, read the question, see if you can set it up and go through A, B, and C, and then come back and check your work. Here it is, so hit pause and give it a try. All right, so the amount of force you must exert on a wrench handle to loosen a rusty bolt varies inversely with the length of the wrench handle. All right, so when I read this, I see inversely, so I know that I'm going to be using the inverse equation, y equals k over x to the n, with the length of the wrench handle. I don't see anything about it being squared or cubed or anything for an exponent, so I'm not going to end up putting anything in for that n value right there at all. Then I need to figure out what is my y variable and what is my x variable. So the amount of force you must exert, that's what comes first, that's your y, varies inversely with the length of the wrench, so that's my x. So if I read this, wrench is 21 inches, inches would be length, so 21 is going to be an x number, and force, that we said that was y, so that's going to be a y number. So after I kind of dissect that initial problem, then I can go to part A. Find the variation constant. That's one answer. And then write the variation equation. That's another answer. So you need 2 different answers. All right, so variation constant. We're going to use this equation. Y, we said, was 90 equals k divided by 21. To solve for k, we multiply both sides by 21. So k equals 1,890. All right, then the variation equation, we take again this equation over here, the inverse equation. We don't put any numbers in for x or y. We only put in the number we found for k. And if we had an exponent, we would put that in as well, but we don't in this case. So our variation equation, y equals 1,890 over x. That's the equation that we're going to use to answer part B. What force would be required using a 7-inch wrench? So 7-inch, that is our x variable or our length. what force, that's our y variable. So we don't know y, but we can substitute 7 in for x, and we get 270. And what is force measured in? Looks like pounds. So 270 pounds. All right, and then part C, the length of the wrench is required to loosen, or what length of wrench is required to loosen. So we're looking for length, which is x. We have force, which is y. So we substitute 50 in for x. I'm sorry, 50 in for y. We have 1,890, but we don't know what x is. So to solve for x, you have to multiply both sides by the denominator, just like we did on the previous problem. So we have 50x equals 1,890, and then we would divide both sides by 50. So x equals 37.8. What were we finding again? The length, and length is measured in inches, so 37.8 inches.